welcome to Plutus IS. So today we will see how to find the order of a permutation. So suppose this is a group permutation group SN. How to find the order of element in permutation group? That means you know that the SN is a permutation group of degree n, and what is the order of this group is factorial n. So now, for example, take any example, like if you take the alpha equal to 1, 2, 3, 4, 5, and here given that the whatever given as the 3, 2, 1, 5, 4, then what will be the order? What will be the order of this element? And this belongs to the S5. Then how to find the order of this permutation or order of this element? And element belongs to the S5, and S5 is the symmetric group of degree 5, symmetric group or permutation group. So how to find the order? So now first write in the, we know that the if any permutation, we know that any permutation can be written as the product of alpha 1, alpha 2 and alpha r in disjoint cycles, in the product of disjoint cycles, product of disjoint cycles and of length respectively, suppose m1, m2 and so on. That means length is the m1, m2, mr are the lengths of the alphas. Okay, then what will be the order? Order of alpha equal to, and disjoint cycles, any permutation can be written as a product of disjoint cycles. Now whatever the given permutation, first write that permutation in product of disjoint cycles of lengths m1, m2 and mr respectively. Then order of alpha is simply LCM of m1, m2 and mr. Okay, so now just first write the permutation product of disjoint cycles, and what is the here m1, m2 are simply the length of the cycles. So now in this example, here alpha can be written as what? Here alpha can be written as, now see here 1 goes to 3 and 1 goes to 3, 3 goes to 1, that means this 2 is fixed, and again 4, 5 and 5 4, that means 4 and 5. So this permutation can be written as product of cycles and product of disjoint cycles. So now 1 goes to 3 and 3 goes to 1, that means 1 3 and 2 is fixed. So 2 just left it 2, and now 4 5 5 4, that means 4 5. So this is a alpha is a product of two disjoint cycles. Obviously these two cycles are disjoint as none of them is the common 1 3, and here the 4 and 5. Then this is a cycle of length 2, this is also cycle of length 2, cycle of length 2. Similarly this is also cycle of length 2. Therefore order of alpha equal to simply LCM of 2 and 2 equal to 2. So we can find the order of this permutation by using this method. We'll take another example. Suppose alpha equal to, given that the 1 2 3 4 5 6 7. Okay, and then now write the here, suppose 1 goes to 4, 4 goes to 2, 2 goes to 3 and 3 goes to 2, and 5 goes to 7 and 7 goes to 6 and 6 goes to 5. Then actually 1 goes to 4, 4 goes to 2, 2 goes to 3 and 3 goes to 1. So 1 2 3 4 5 6 7, now 5 goes to 7, 7 goes to 6, 6 goes to 5, and we have to find the order of alpha. So every permutation, now this is the element of, this is the element of S7, and we have to find the order of this element, and first write the given permutation in the product of disjoint cycles. So this can be written as alpha equal to, you can see that the 1 goes to 4 in cycle, so 1 goes to 4, 4 goes to 2 and 2 goes to 3 and 3 goes to, where the 3 goes to 1, 1 goes to 4, 4 goes to 2, 2 to 3, and 3 to 1. So 3 to 1 dash cycle, and here the 5, 7, and 7 goes to 6, and 6 again goes to 5. So this is a, so now alpha can be written as a product of these two disjoint cycles, and here the length of 4, here the length of this cycle is 4, and length of the second cycle is 3. So this is a cycle of length 4, cycle of length 4, and this one is a cycle of length 3. So you can find the order of this permutation equal to simply LCM of 4 and LCM of 4 and 3. LCM of 4 and 3, you will get the 12. So order of this permutation is 12 in S7. So similarly, we can find the order of any permutation. To simply to find the order of any element in a permutation group, first write the given permutation in the product of disjoint cycles, then find the length of all the cycles, and then calculate by using this formula order of equal to, that means order of permutation equal to LCM of M1, M2 and MR so on. And what are the M1, M2? Are simply the lengths of the cycle of disjoint cycles alpha 1, alpha 2 and alpha so on. So we can find the order of element by this methods. So we will discuss more about the permutation group in the upcoming videos. Thank you.